Hi friends, today we are going to see about fuzzy logic. In fuzzy logic, in particular we are going to see about what is meant by fuzzy sets and what are the types of fuzzy sets. So, we already aware of what is meant by set. In maths we have already studied that. So generally we have an idea about what is meant by set. Here there are two types of sets we have to know. One is the crisp set and the other one is the fuzzy set. So what is meant by crisp set? In a set called crisp set, the values will be either 0 or 1. But in the fuzzy set, the values will be intermediate values, that is between 0 and 1. For example, it may be 0 0.7, 0 0.06 or 0 0.5 like that. We'll get the intermediate values between 0 and 1. Those type of that type of set is called fuzzy sets. So, for identifying the function, in a crisp set, the function is known as characteristic function, whereas the function of an fuzzy set is known as membership function. So, the membership function represents the degree of membership. Later, I'll explain how we are going to find the degree of membership. So, these are the general fact about the fuzzy sets. So the exact definition of fuzzy set will be: consider there is a set called capital X. If X is a universe of discourse, if the capital X set has all values inside it, and the small x be any particular element of capital X. So in the universe of discourse, and on particular values will be a small x. So for finding the fuzzy set of the general set capital X, the fuzzy set is denoted as A here. Here we are denoting the fuzzy set as A. The fuzzy set A defined on X is a collection of ordered pairs. You can see the formula A equal to where x comma mu A of X. So here the mu value is called the membership function value. So the mu value will be the membership function value. This is the formula for finding the fuzzy set. For a clear explanation, I will give. Now let us see an example how we are going to find out the fuzzy set for a normal set. So capital X equal to, there will be a values 1, 2, 3, 4, 5, 6, 7. This is the set. For this set only we are going to find the fuzzy set values. So here what we have to find out is, the condition will be we have to find the number close to 3. So we are going to find out which are the numbers that are close to 3 and in what distance they are having a relationship between the each numbers. So now consider the element x in capital X. So the small x will be each element. So one will be one type of small x value and two will be the small x value like that. So the small x, first we are going to take 1. So small x equal to 1. So the mu A of 1 will be, that is the membership value of the 1 will be 0.5. How we are getting the 0.5 value means this is our assumption value. So manually we can set any value between 0 to 1. So 1 is bit farer to 3. So 2 will be the most closest value. While considering the 1, it will be bit farer to 3. So generally we are assuming the value will be 0.5. So the mu A of 1 will be 0.5. This is our manual value according to our understanding view. So now the second element, what is that? X, small x equal to 2. We can take the 2. So the mu A of 2 equal to 0.8. Again, this is a human uh, set value only. Why it is 0.8 means it is very closer to 3. It is a closest element to the 3. So the value will be 0.8. Next, small x equal to 3. So here the membership value of 3 will be 1 because already we have to find which element is close to 3. So the exact same 3 value means then that is fully satisfied. So that is equal to 1. Then x equal to 4. Again, while considering the 4, it is same like that of 2. So this is so this 4 value will also get the same 0.8 value, and 5 means it is like that to 1. So the same 0.5 value is for x equal to 5 also. X equal to 6. This is bit farther while comparing to 5. So this will be 0.1, and x equal to 7. This is too farther. So we will set this value as 0. Now the fuzzy set, what we have seen in the definition, it is a collection of ordered pairs. So capital A equal to x comma ua of x, that is the formula, right? So the small x value, 1, and the ua of x, the membership value of 1 will be, what is the membership value of 1? It is 0.5. So A equal to 1 comma 0.5, and next 2 comma 0.8, 3 comma 1, 4 comma 0.8, till that 7 comma 0. So this is the fuzzy set value for the capital X set. Hope you all understand how to find the fuzzy set for a normal set. Next we are going to see about the types of fuzzy sets. Generally there are 4 types: normal fuzzy set, subnormal fuzzy set, convex fuzzy set, and non-convex fuzzy set. We will see in depth what is these types of sets and their general concepts. So in the 4 type of fuzzy set, the first type is called normal fuzzy set. So previously we have seen like what is fuzzy set and how we find out the fuzzy set for a normal set X, capital X. Now, if what is the normal fuzzy set means? A fuzzy set whose membership function has at least one element X in the universe, whose membership value is unity, that is 1, is called normal fuzzy set. So what it means, we have find out the fuzzy set, right? For in the previous example, we have take that capital X equal to 1, 2, 3, 4 till 7. There are 7 elements in the capital X set. At least one element of the capital X should have to meet the membership value equal to 1. In the previous example, so the number 3 meets that condition. So its mu a value will be 1, like that. At least one element in the set has the membership value as 1, then that type of set is called normal fuzzy set. So that is called normal fuzzy set. Then that type of set will be normal fuzzy set. At least one element should meet the value 1 as its membership value. Then the second type is subnormal fuzzy set. Here a fuzzy set wherein no membership function has its value equal to 1. So uh, consider the set has 5 elements in it. In that 5 element, no element, at least no element will meet the membership value as 1, then that is called, all the 5 elements are having like 0 0.5, 0 0.6, 0 0.7, none of the element has the value, its membership value as 1, then that type of set is called subnormal fuzzy set. Then the third type is convex fuzzy set. Here it is a bit very, it will be very like not like normal and subnormal fuzzy set. Here the concept of fuzzy set is the membership function have to be strictly increasing, either it have to be increasing or it should be decreasing. So the initially the first value of a set has the membership value as 0.1, then the second value of the set have to have the value as 0.2, then the third value as 0.4, then the fourth value as 0.6, like that. It should be increasing, the membership value should be strictly increasing, or it can be decreasing. That type of concept is called convex fuzzy set. I hope you got that. So either it have to be increasing membership value, or it has to be decreasing membership value. That type of fuzzy set is called convex fuzzy set. Then the intersection value of two convex fuzzy set will be also be and again a convex fuzzy set only. If you intersect two convex fuzzy set, then the output set also will be the convex fuzzy set. Then the non-convex fuzzy set, final category is non-convex fuzzy set. It is the straight opposite to the convex fuzzy set. Here the values will be increasing and the second value will be decreasing. Again the third value will be increasing. It does not meet the condition like convex fuzzy set. Here the values will be random values. It will increase, decrease, again it will increase like that. Here the values are not continuous. So it is straight opposite to the convex fuzzy set. That is called as, that's why it is called as non-convex fuzzy set. So these are the four types of fuzzy set. What is meant by fuzzy membership function? Already we have go through that fuzzy membership function. Once again I am repeating here. The fuzzy membership function defines the fuzziness in a set irrespective of the elements in the set which are discrete or continuous. So the either the element may be discrete value or continuous value, that is not a matter here. So for what type of values also you can find out the fuzziness for a particular value in that set. So that is the fuzzy membership function. Generally the membership functions are generally represented in graphical form. So the membership functions are often denoted in the graphical form. So the formula is A equal to, how we are going to find out in the first slide itself we have seen the formula. Again I am repeating, A equal to x comma mu a of x, where every small x belongs to the capital X. So this is the formula for finding the fuzzy membership function. So the next we are going to see about the features of membership function. Initially we have seen what is meant by fuzzy set and how we see an example about how we are going to find out the fuzzy set. That is how we are going to find out the membership function of a element in the set. Then we have seen about the types of fuzzy set, and now finally we are going to see about the features of membership function. So in this diagram you can able to see there are three important things: the core value, support and boundary. So these are the three important features of an membership function. So the membership function value is in between 0 to 1, that we have already seen. And what are these three important features? Core, support and boundary. Now let's see about that individually. First one, the core. So the core means the core function of a membership function for some fuzzy set A is defined as the region of universe that is characterized by a complete membership in the set A. So what is mean by this complete membership? So in a set, if an element meets the value 1, then that is called the complete value. That is the complete membership value. So the what are the elements that meet the value 1, that type of elements come under this core value. The core has element x of the universe such that mu a of x equal to 1. So it is simply, it means in an set with some few 5 values, for example, the third element meets the value 1, then that element belongs to the core value of the fuzzy set. So the core of a fuzzy set may be an empty set. So, it is possible, right? There may be a chance for not meeting 1 in a set with 5 values. So each element membership value will be less than 1. There is a chance. It is not mandatory that at least one element should meet the one value, that is the core value. So there is a chance for getting an empty set also, that is without a core value there may be a set exists. That this is called the core concept. Then the next one is support. What does mean by support? Here what it means the support of a membership function for a fuzzy set A is defined as the region of universe that is characterized by a non-zero membership. So what does mean by this non-zero membership? Here what it means each element in the X should have a membership value greater than 0. So there should be a no zero holding membership value for an element. So in a set, if there are 5 elements, each 5 elements should have a membership value greater than 0. So the type of elements comes under this support category. A fuzzy set whose support is a single element in X with mu A of X equal to 1 is referred to as fuzzy singleton. So in the support feature, there can be a element with the value 1 or greater than 0. So if this if any element having 1, at least only one element is having the value 1 means, then that is referred to as fuzzy singleton. So again, once again I will repeat. In a set, in a fuzzy set, if an element holding the value equal to 1, then that type of values comes under this core feature. Then support means the membership value of an element should be greater than 0. That type is called as this support values. Next one. So next type, the last feature is boundary. The support and boundary is almost similar. The boundary of a membership function for a fuzzy set A is defined as the region of universe containing elements that have a non-zero but not complete membership. What it means in the boundary area there may be an element with no membership value, or there may be an element with a membership value. So this area includes both the elements. That type is called boundary. So these are the three important features: the core, support, and boundary. These are the features of membership function. And there is a point called crossover point. This is very simple. Crossover point is nothing but the element in a value having 0.5 as membership value. So the values will be between 0 to 1, right? If an element particularly having the value 0.5, then that then that point is called as crossover point. The element holding 0.5 as a its membership function value. Then mu a of x, when mu a of x is equal to 0.5, then that element is called as crossover point, then that value is called as crossover point. I hope you had a good idea about what is meant by fuzzy set and its types and features. Thank you.